Welcome in this session. I'm going to discuss polarization part 2. I am HR Ingole, working in MBSK Kanya Mahavidyalaya Kadegaon district, Sangli, Maharashtra. Now polarization means whenever light contains the vibrations only in one plane, then that kind of light is called as a polarized light, and the phenomena in which unpolarized light converted to polarized light, that is called as a polarization. Already we discussed polarization in part 1. Today we are going to discuss the production of elliptically and circularly polarized light by using device, and that's why I have given name for this part as polarization part 2. This is the same part under topic of the polarization. I divided this topic into two parts, polarization part 1 and polarization part 2. Now look here, here is our in this figure you will see that this is the crystal cut in specific manner, and suppose this is a calcite crystal of certain thickness of this crystal. Whenever plane polarized light is incident, suppose normally on the principal section of this crystal, this is the principal section of the crystal, and this light is incident normally on the principal section. As it incident normally, we all know without deviation it goes further and emerge out from this another end. Okay, when this light is enter here, at that time it divide into two parts, because calcite is double refracting crystal, and as soon as it enter in the crystal, it divides into ordinary ray and extraordinary ray. The vibrations which are in this plane and along the optic axis, that is extraordinary vibrations, and along this axis they are ordinary vibrations. Now this crystal, calcite crystal, is a crystal having thickness is in such a way that whenever this ordinary and extraordinary rays coming out of this crystal, at that time part difference of lambda by 4 is produced here for this particular wavelength, for this monochromatic wavelength which we use here. Therefore this crystal which produces part difference of lambda by 4, that's why its name is quarter wave plate. This plate is called as a quarter wave plate. As it produces a path difference lambda by 2, it is equivalent to phase difference of pi by 2, that means 90 degree between the ordinary and extraordinary rays. We all know when ordinary ray come here at the other end of this crystal, at that time it performs simple harmonic motion in this way along the x-axis, and extraordinary ray perform simple harmonic motion along the y direction. So how we can represent ordinary and extraordinary vibrations at this end? We can write along this, suppose amplitude of the ray into sine theta, sine omega t, not theta, sine omega t, and for the x-axis what we can write? These vibrations are ordinary vibrations having a, that is amplitude, into sine theta, sine omega t minus delta. What is delta? Or delta is nothing but a phase difference, but delta having value pi by 2 here, because we have know that is this is the quarter wave plate produces a part difference of lambda by 4 or phase difference of pi by 2. Therefore, whatever may be here, omega t angle is there, then for this omega t minus pi by 2 will be there. Okay. Next, now what is amplitude of these vibrations along this? What is amplitude of this vibration? We know this amplitude of this incident light is A. It makes an angle theta with this optic axis. So I can resolve this into two components, along the optic axis and perpendicular to the optic axis. Okay, just you see now, same figure is shown here. Okay, now this is A. So how much component of A is here along optic axis? A cos theta if this angle is theta. And how much is this? A sin theta according to our simple trigonometry. Okay, so amplitude of this vibration along the optic axis, that is A cos theta, and along perpendicular to the optic axis means along x axis, that is A sin theta. Now let us, we will say it is suppose small a and this is suppose small b. Okay, so we can write now like this. For what is displacement along y axis? Displacement along y axis, that is nothing but a E ray vibrations. So y equal to amplitude along y sin omega t. We know this is simple harmonic motion along y which represent E vibrations. What about the O vibrations? Similar to this, x is equal to, because it is along x axis, x is equal to amplitude. We know B is amplitude there, sine of omega t minus pi by 2. Here is omega t is only, and here minus pi by 2 additionally come there, because phase difference between this ordinary and extraordinary is pi by 2. Okay, but we know sine omega t minus pi by 2 is nothing but cos omega t. That's why we written it. Okay, now take this b on this side, so you get x upon b is equal to this, and y upon a is equal to this. So these 2 and 3 equations are for extraordinary and ordinary respectively. Now squaring and adding these 2 equations, what we get here? Square here, then get a y by a bracket square is equal to sine square omega t, x by b bracket square is equal to cos square omega t. And if you add these 2 squares, after squaring, if you add these equations, then you will get a this square plus this square is equal to sine square omega t plus cos square omega t, that is the 1. So we get it like this. Okay, and now if you give individually here square, then we get a this equation. We know this is the very fundamental equation of ellipse. Okay, so we can say that if whenever this plane polarized light is incident here, making an angle theta with the optic axis of the crystal, then the emergent light from the quarter wave plate is elliptically polarized. It is elliptically polarized, and so we get an elliptically polarized light. Now we know what are values of A and B. We know A is equal to A cos theta. A cos theta we consider it as A, and A sin theta as a B we taken. If here now, whenever we take, suppose if we taken that angle of incidence, if angle of incidence here theta is equal to 45 degree. Okay, this angle is 45 degree. Then what will happen? Then what about this value and what about this value? Take here theta is equal to 45, theta is equal to 45. We know here cos 45 1 upon root 2 and sin 45 is 1 upon root 2. So this value will becomes A by root 2 and it also becomes A by root 2. Means amplitude A, we know this is a small a. So small a is equal to A by root 2 and this small b is also A by root 2. Means both values becomes equal. A and B becomes equal. Okay, and as A and B are equal, put it here, put these two values here. b equal to a. So we will get x square upon a square plus y square upon a square is equal to 1, and because of that you will get a finally x square plus y square upon a square is equal to 1, and then take a square here, you will get it like this. So this is the very fundamental equation of circle whose center is at the origin of the coordinate system, and it has radius a. Okay, so this is the circle, and that's why we can say that the emergent light from the from the quarter wave plate is now circularly polarized. Okay, so in this way we can produce circularly polarized light. We can produce also elliptically polarized light by using quarter wave plate. Only whether how could we produce elliptically and how we can produce the circularly polarized light, that is depends upon only angle made by the vibrations with the optic axis. When there is 45 angle, then definitely there is circularly polarized light. For all other angles, it will be the elliptically polarized light. So in this way we can produce elliptically as well as circularly polarized light by using a quarter wave plate. Okay, now let's stop here, and we'll go back. Now I will go back here now uh, after completion of this slideshow is completed now here, and here, excuse me, and